Okay, hello. Um, Welcome to section 7.4. 7.4 is going to be more of what we've been doing the last 2, 3, 4 sections. Just going to introduce you quickly, actually, to some sum and product to sum formulas. Just again, you might not always use them, but got to show it to you and let you just get accustomed to being able to use any formula on an as-is basis. That way, no matter what problem comes at you in the future or in calculus or whenever, you can handle it. And usually you can find some kind of identity to help you out and condense things or expand or verify uh, different statements and so forth. So learning objectives in this section, we're just going to express products as sums and express sums as products. We're just going to go back and forth. And really, I'm going to try to do this all in one video. So we'll see if it works. I'm not going to rush. But again, the only way I really know how to show you all this, besides showing you the exact formulas, and you can look those up in the notes, they're also posted. It's actually just to crank out some problems and then kind of take turns with you as if you're playing along here. So let's look at the product to sum formulas first. And by that, all I mean a product meaning cosine of some angle times cosine of another angle. Notice these are all the combinations that can happen: cosine, cosine, sine, 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 cosine, cosine, sine, in any order. And really, what these formulas crank out, the reason why they're called product to sum formulas, is because, or you can call them, I guess, difference. Um, but there's sums or differences in the translation here. Notice here, here, so forth. Okay, so let's go ahead and just jump right into a problem. I'll show you kind of an instance where you can use these, and I always have to look at the formulas. So don't be bad. I don't have these, or don't be upset if they seem a little convoluted to you. So here we go. We got cosine times cosine. And right off the bat, because it's cosine times cosine, you're going to notice I'm not even phased by really paying attention to the angles. And we will in a second here, but I got to figure out what formula I want to use right off the bat first. Now, if the choice is write it as a sum or difference, in other words, they're letting you choose out of the four possible identities there, we're going to choose the one I just starred, and we're just going to copy down the formula. And when we copy it down, we're just going to put the right angles in the right spot. So there's 1/2 cosine. Now this is going to be like alpha, and this is going to be like beta in the formula. See what I'm looking at? So cosine of alpha here is, looks like 3 theta minus 5 theta, because there's beta. Okay. Put some parentheses on that. And I'm really just ripping off the formula because I don't have it memorized either. Cosine 3 theta minus 5 theta. I'm sorry, I put a minus and I shouldn't have. It's a plus. As long as you get the pluses or minuses down, which is kind of the big deal. Notice you have a minus here, our minus, and a plus here, so we have our plus. And when all said and done, we have 1/2 cosine of, I don't know, minus 2 theta plus cosine of 8 theta. And that's all we can do, believe it or not. There's nothing else to do because I don't know what theta is, and I don't have a triangle or anything to reference it with. Don't know what quadrant I'm in, and so forth. So just as far as straight up translating, excuse me, um, from one formula to the other side, as long as you can pick the right formula to start with, that's kind of the key to the whole thing. And notice I only chose this starred formula here, in this case, because I had cosine times another cosine. Okay? And that once you're that far, I mean, you could push the 1/2 through, but there's no need. I mean, it's not going to benefit you one deal. So when that's all you can do, you just leave it. You're done. All right, so I'm going to challenge you. This time we're actually going to try to find some value because you know the angle. Use these formulas, pick the right one, and I'll have to tell you it's the same formula we just used. But now put in the right angles, would you? Okay, pause the video, and when you come back, we'll start right there. Okay, if you're playing along here, you should be like, well, this isn't that bad. I'm just going to put 1/2 and copy exactly what we did from up above. And if you need to see it, we can kind of go there. But cosine of pi, I'm sorry, 11 pi over 12, right? Oh, I said cosine, but my hand didn't write it. So let me get back in there. So the cosine of, let's see, 11 pi over 12 minus pi over 12 plus, remember that's important, I'm looking up here in the formula. So one's a minus before it, and the other one's going to be a plus on the back end here. So cosine of 11 pi over 12 plus pi over 12. And as long as you can get that far, really, that's kind of, I guess, as hard as it's going to get. That's why we only have one video this time. But check it out. So now you have cosine of 10 pi over 12, which we can reduce in a second, and the cosine of 12 pi over 12. And as you continue on, cosine of, oh, if I take a 2 out of top and bottom, what is that, 5 pi over 6? Plus cosine of, what, pi? See how these just whittle down to something more, a little bit simpler, or a lot simpler, actually. And this cosine of 5 pi over 6, we're going to go ahead and use a reference angle. Remember, on a unit circle, 5 pi over 6 is here, so pi over 6 is my reference angle. And all students take calculus. So when I use reference angle, it's going to be negative cosine of pi over 6 plus, and the cosine of pi over here, remember that's just minus 1, 0. So that's going to be minus 1. Cool, huh? So on your chart in the two circles, I'm assuming you know what those are by now, you are going to have 1/2, and then this is going to be minus, what does it say on the chart in the two circles? And if you can't, if you don't have it in front of you, maybe you can see it in your mind, or one way or the other. I think that's probably root 3 over 2. Now notice I got to change this minus 1 to add it to minus root 3 over 2. So I'm just going to say plus minus, because I'm writing over the top of stuff, 2 over 2. I'll take this up here. You're going to have minus 1/2 the quantity minus root 3 minus 2 over 2. And that minus you can shove through everywhere if you want to just simplify stuff out. And you're going to end up with root 3 plus 2 all over 4, because 2 times 2 on the bottom there's 4. Notice this was patched up top. And that's as fast as it goes. This is the exact answer. No need for your calculator one bit. Okay? So that's going from, just two examples, going from a product to a sum. Now, the only other thing we got to do is go backwards, go from a sum to a product. And there are those formulas there. Notice all the different versions they've come up with. You can use them as long as they present themselves accordingly. So out of those 4, we have sine of some angle minus sine of another angle. What formula do you want to choose? Excuse me. And if you're saying this one over here because there's a minus, right? They're calling it sum to product, but we can call it sum or difference to product too. All you have to do, and these are a little hard because there's a couple spots, there's 4 different angles you got to plug in here. But if this is like my alpha, right, from there, and this is like my beta from here, all you have to do is throw in 4 pi everywhere you see an alpha. So, or 4 theta. So watch, 4 theta. I'm cheating right now. 4 theta. And all you have to do is throw a 2 theta where you see a beta. 2 theta. Can you see that? So even in this formula, if I rip it off, and I'll erase it in a second, but you're going to have, oh, 2 sine 4 theta minus 2 theta all over 2. And I tried to draw right over the top of that so you could see how so fast and easy you can make these things. So it's 4 theta plus 2 theta all over 2. See the transformations? And I'll erase this stuff for you now. But again, all of these are find the right formula, plug stuff in, and then crank the thing out. So at this point, it's just 2 sine 2 theta over 2 cosine 6 theta over 2 here. 2, now watch what happens. Sine of theta. This is cosine of 3 theta. And again, that's just because 6 divided by 2 is 3. Because I don't know where I'm at, I don't have anything else, you're done. And yep, it is that easy. So let's do a couple more here, and we'll call this whole video done. And that'll be it for this section. Kind of cool, huh? So let's use something in degrees now. We did radians before on the last page. So evaluate cosine 15 degrees minus the cosine of 75 degrees. All right, I'm going to go up, identify my formula. This one. And then I'm just going to copy this. So that's going to be equals of minus 2. Now remember, you got to put alpha and beta both in there. So 15 degrees plus 75 degrees. And don't shorten that parenthesis too much. Make sure that 2's in there. And then times the sine of 15 degrees minus 75 degrees. Now once you have that transformation, notice now that's this difference here is now written as a product of two sines, or sine times sine of something. So 2 sine 90 over 2 sine of this is minus 60. Again, I'm going to come up even higher this time because I need more space. So what is that, 45 degrees? Remember, this is a product. They just don't put it in parentheses or write a times sign. This is minus 30 degrees. And again, minus 2. This is just root 2 over 2. And remember, if I use a reference triangle, this is going to be minus. And in my head already, I'll erase this in a second. Down here, minus 30 degrees. 30 degrees is still going to be your reference angle. And the sine of 30 degrees, right? All students take calculus, has to be negative. So it's going to be negative 1/2. And at that point, all you have to do is clean stuff up. This 2 goes with this 2. And you end up with negative on the front and a negative there, so it's positive. So you're going to have root 2 all over this bottom 2 here, 2. Done. Crazy, huh? So now we'll have a different way, or yet another way, I should say, when we have, we've had all sorts of formulas. Some are difference identities and things like that. But now if you have a difference of cosines or a product or something like that, you know how to handle it. So let's do one more, and let's go ahead and prove it. And this time, for the last one here, I'm going to ask you to do it, as usual. And I'm going to start on the left side. I want to finish on the right side. I want to finish here, okay? So left side's a little bit more messed up, but use the formula on the top, which means you're probably going to use, again, I keep starring these things, but yeah, go ahead and use this one that I'm erasing. And then on the bottom, so you have cosine minus cosine on the top, and sine plus sine on the bottom. So you're going to use this one on the top, push in the right direction, and this one on the bottom. Got it? So there's a difference on the top and a plus on the bottom. Go for it. Pause the video, and when you return, I'll help you. Okay, if you are playing along, here we go. I'm just going to crank this out. On top, you should have minus 2 sine. Now, I can't see that formula, so I'm looking at the formula on a different piece of paper here. You should too. Don't just believe me. 4t minus 2t over 2. And on the bottom, you're going to have 2 sine. All I did again is I used those top 2 formulas as I was suggesting before. I told you the 2-star one, the black star and the blue star up here. And once you're done now, start reducing some things. Now check this out. This whole quantity here, because it's all multiplicative, can go. This 2 goes with this 2, and I'm going to end up with negative. Well, check this out. I have sine of the angle, which is the same thing as the sine of the angle. We could whittle that down if you want, but it's going to be the same thing. Check it out. 4t minus 2t is 2t. Divided by 2 is just t, yeah? And same thing for the bottom. So all I'm doing is simplifying inside the angle here. And that is going to give me minus tangent t. You're done. So that's all you got to do. One video for this section. Fantastic job. Get ready. Next stuff coming up is a little bit more involved, but this week should be nice in the sense that these are just formulas, and once you learn how to put the puzzles together, so to speak, things should be pretty good. Okay? Good job, and I'll talk to you soon.